I'll start with one of the problems which I'm sure a lot of you are very interested in, the measurements to changes problem. It's a very common problem. I have some data set, I have some measurements. Where do these measurements change? Why don't we take a look? Here I have some data, and this data represents trades that are performed on particular assets. I buy, I sell those assets, and the accumulation of the buys or the accumulation of the sells give me a position. That position could be a long position or a short position. A long position if I am net positive in my buys, or a short position if across all of the sells, all of the trades, my position is net negative. Well, if you think about it, anytime you perform a trade, you're getting some pricing information from the market. And so what you might want to do in order to construct a bid-ask spread that you know is actually backed up by real data because the market has shown you somebody's willing to trade at that price, well, you might want to say for each individual position, every time I have a consecutive series of positive volumes or negative volumes, that constitutes a position. Well, grouped by that aspect, how do I determine what my average buy price is or my average sell price? And this is very much a problem of trying to figure out where something changes, specifically where your net volume changes from positive to negative, or from positive to zero, or from zero to negative, or whatever the case may be. So this is the raw data that we'll look at. Now, before we get into this, let's talk a little bit about some background and a little bit of some theory. It is absolutely the case that this is a problem that is relatively easy to solve in pure Python. If we think about how we solve this in pure Python, we might think we have some sequence of values, say ABC, ABC, and then a DEF, and then an XYZ, and then maybe the XYZ repeats again, and then we have an ABC. If we have some raw Python data here, we might want to identify, well, when did this actually change? When did we change from the ABC to the DEF? And if you think about it, the change points here would be on this element, on this element, and on this element. We want to figure out how we changed. Well, if you think about how you might go about doing this, it might be you can understand this analysis by looking at a very simple window. You just have to look at a window of what the current value is and what the last value is. You just say, is the current value not equal to the last value? And so it turns out that you can solve this quite easily. You could say something like previous value equals none, for current value in x's. And I guess maybe we could even say the previous value equals x is 0, and then we could go from x is 1 to the end. We might say the previous value is whatever the current value was here. And then we could say if the previous value doesn't equal the current value, then we see a change. And we can even identify where it changed. We could do something like enumerate these, starting from 1, and say we changed at some index. And this is a very naive way to go about solving this because we know in pure Python we even have better approaches than this. And you can see it identifies that we changed at 2, and it'll even tell you from what previous value to what current value. So it actually ends up being pretty easy for us to solve in pure Python. In fact, we may know that there are even better ways to solve this problem in pure Python, making use of things like the itertools module and making use of iteration helpers. We could use itertools.pairwise to solve this problem, and that makes our life even easier because we can then loop directly over the previous value and the current value in these values as pairs. And we can basically say, if the previous value didn't match the current value, that's where. And by the way, what we'll do is we'll enumerate this result so we can get this as well. That's where we saw a change. And you can see this code is even better than what we had started with. It's a little bit clearer, and we've moved more of the complexity up into the loop header. Obviously, we'll have to just make sure that our indices are right. So maybe we start this from 1, and there you can see we get the same result. And we might even know how itertools.pair works. It more or less just need to take one data structure and zip it with that data structure adjusted. So we may even go as far as to do something like create our own better version of pairwise, maybe an n-wise. And I'm sure many of you have seen me do this before. N-wise is just the generalization of pairwise for windows of arbitrary size n. And the trick for this is just you zip the islicing of some iterable from some starting point to its end for each one of these enumerated like that. And of course, you'll T there just so that this can be something like a generator. And so I'm sure many of you have seen me write an NYs before. All of these, very easy to solve in pure Python. But we know if we're going to solve this problem in pure Python, then we are going to be iterating on the scope of the data, which is basically not making use of pandas or NumPy at all. It is problematic whenever we see some sort of loop at the Python level where that loop's cardinality, or the number of times that loop is going to operate, is on the scope of the data, and that's exactly what will happen if we try any of these approaches here. So we need to find an approach that stays within the restricted computation domain that can be expressed in terms of vectorized operations. Well, it turns out that this is actually fairly straightforward to do. There's just a little trick associated with it. When you think about how NYs works, and you think about it being basically the identification that if we have some data and we zip it with itself, and then we zip it with itself with one element carved off, we get pairs of size 2. If we zip it with itself with 2 elements cut off, we get windows of size 3 that are overlapping. Well, this trick here is basically the idea behind things like pandas.Shift or pandas.Diff on a series. And so what we could do is we could take the values that we have and we could shift them. And you can see when we shift them, we get the next value and the previous value. We could take the current values and see if they're equal to that shift, and we can make use of one other trick here. Remember, it is very much a deliberate choice in pure Python that true is equal to 1 and false is equal to 0, and it is very much a useful trick in NumPy and pandas to make use of true being 1 and false being 0. Well, what we could do is we could identify where this changes. And you can see here we now get a false value every time the value is the same, and a true value anytime the value is different, starting with, of course, a true value at the very beginning. So if we look at the data, you can see here we get a bunch of false values here where the value hasn't changed, and a true value every time the value does change. Because true is equal to 1 and false is equal to 0, if we compute the cumulative sum here, you can see that those falses just don't add anything to the sum, and the trues add something to the sum. You can see we have now grouped this data into everything that constitutes the very first repeated sequence of values and everything that constitutes the second repeated sequence of values. And if I make my data a little bit bigger, you can see this works quite well. You can see that first batch, and then there's nothing. Then there's something here, then there's a bunch of changes there, and I guess there's not enough repetitions here. Why don't we change our seed a little bit and see if we can force some repetitions? There we go. You can see there's a sequence of 3 values here that are repeated, and you can see that right here in the data. Just using a couple of these tricks and thinking a little bit about how things like NYs work gives us the ability to find sequences of the same data. It is not the case that we could solve this problem using things like groupby. Because if we did something like a groupby on the underlying data, and we tried to tell it, oh, no, don't sort the data, just group by anything that matches, this won't work. We might think it works because that's another way we could solve this problem in pure Python. It's very common that we might see that instead of using something like itertools.pairwise, we might use itertools.groupby. And itertools.groupby requires that you sort the data. Otherwise, it will group together these data together. And so here, this would give you each key and each group. And this would actually show you how these values group up. So you'll see this gives you the sequences of A, B, C, then the sequence of D, E, F, then the sequence of, and I'll even show you, let's just do, don't think you can find the length of this. So let me do sum1 for whatever in G. Show you the length of this. So you can see here this identified the 2 values for ABC, the 1 value for DEF, the 2 values for XYZ and ABC. That's how itertools.groupby works. But pandas.groupby, even if you tell it don't sort, it's not going to work that way. And so this is still going to, if you take a look at the groups that it gives you, it's still going to give you the groups of all of the ABC values, the XYZ value, and the DEF values, not the contiguous values. And so here, you have to use this contortion or something similar. You can't just use a .groupby without sorting like you could with itertools.groupby. Well, let's take a look at how we'd go about solving this problem. Here's the answer. We started with our trade data. And remember, for this trade data, It indicates trades that were done across multiple days on different portfolios. So we're going to add a little bit of complexity here just to make sure that this solution works even in the case of something a little bit more complex. We're going to probably group by the portfolio and the asset. Obviously, we are talking about each position per book, per trader, per asset. And so if we do something like the regular sum here, you can see that's the net position that each portfolio had for each asset at the end of this sequence of trades. And of course, that sum on the price isn't very meaningful. That doesn't mean anything here, but here, just the sum of the volumes. Well, we don't want the sum of the volumes. We want the cumulative sum of the volumes. And we know when we do something like a cumulative sum, it's like a pandas group by transform. It's going to preserve the original indexing. And so here you can see we have all of the data in the same formulation, in the same structure as the traded data. But now that value there for the volume is the cumulative volume, how much of that trade you happen to have as of that point in time making use of that one trade. And we can add that into our structure with a pandas assign. So we can do something like this. This will be the total volume or the cumulative volume. So we could do something like this here. And that gives us the first part. Whoops. There we go. Now, we have the cumulative volume. We need to figure out if it's a long or a short position. Well, that's pretty straightforward for us to do. We can just ask the total volume, is it positive or is it negative? One little trick here that we might do is we might consider that the position resets at the end of the day. And that adds a nice little degree of complexity and real-world complexity because it's something that we actually did very recently for somebody. But what we might do is we might take this grouped by the portfolio and the asset and the date. And of course, here, these are already grouped under the day, but you can see there's multiple trades per day. And we might take the last value for this. So that's what the position looked like at the end of the day. And we might say this result is your total end of day volume. And it's oftentimes very useful when we're doing these kind of problems with pandas that we do them step by step like this so that we can see what the intermediaries look like. So here we have the total end of day volume. And of course, here let's just double check that that index aligns. Here, this result looks exactly like our original result, but you can see this indexing here doesn't match exactly. So we just need to make sure that that index aligns properly. The way that we'll do that is we could do this as an explicit transform and have the transform do the broadcasting. So we could just take what the iloc -1 value is. And here you'll see that gives us identical indexing. And so that's one quick and easy way we can make sure that we can assign this back in without the index alignment complaining. That index alignment is the most important thing. Probably almost every question that comes up, maybe not every question, but 90% of the questions that come up on Stack Overflow about pandas really come down to, did we index align correctly or not? Now let me do a dot values here to see if I can force that. Oh, and I want to do this on just the volume column, and that's why it's not aligning properly. So there we go. So there we go. Now that's my total end of day volume. Once I have my total end of day volume, I can identify whether that is a long or a short position. It's just whether the total end of day volume was 0 or not. And I like to make this a true false value. And since it's a true false value, I don't want to make this like a string long or short. I'll just make this a true false value like this. So here you can see that's my long position. And then this is the field that I can use my little where does this change trick. Just to show you that this works, I'll show you that we should have some short positions in here. So let's just quickly see if we can identify any places where we had a short position and see if that makes sense. And let's do where this is not true. So here we should see, you can see here there's a bunch of short positions. So this trader happened to not have a very good view of EVQX and decided to short that position instead. Well, now that we do that, we want to see where the position changes. So we could identify the position number using the same trick that we saw before. We'll take the data frame, we'll take the long position, we'll see where that's not equal to the long position shifted by 1. We'll take that result and we'll compute the cumulative sum over that. And that should give us what position number we're in. Now, of course, we can't cross assets and we can't cross traders. So we'll, of course, need to do this grouped first. So we'll do a group of this long column like this, we need to group this. And we have to group this by the portfolio and the asset. And then once we group it by portfolio and asset, then this will be a transform operation because we'll retain the original structure, and it'll look like this. So here, we'll go here and replace that with our representation of the group. And I actually sometimes like to call this G for group, like that. And there we go. So that gives us our position number. And you can see, of course, on day 1, you're at position 1. And then the end of this is actually pretty straightforward. We now have a column that we can use in order to identify where the positions are. We can group by that. We couldn't group by the original data because pandas will just group each one of the similar items together. That's how pandas necessarily works. But here, we actually have a field that we can group on. So we'll group on each portfolio and each asset and each position. And if we wanted just the overall average price, we could just take the mean of the price. If we wanted the average buy price and the average sell price, we just have to add another synthetic column that indicates whether it was a buy or a sell, and then just do this grouping on those as well. So we just have to do something like identify if this is a buy or a sell, which is pretty straightforward. We do lambda df. We take a look at the volume. It was a buy if the volume was positive on the trade, not on the total volume. So we have the buys and the sells. And then here, we would just want to group by the position number and whether it was a buy or a sell. And maybe what we'll do is, we'll group it like this. And actually, what I want to do here is I actually will unstack whether it was a buy or sell, just to make this a little bit nicer. Actually, no, I'll keep it there. I'll keep it in line, and then I'll unstack at the end. So we'll group on whether it's a buy or a sell, and now you can see that's the average buy price and the sell price, and then we can unstack whether it's a buy or a sell, and of course, rename these axes. So here this would be, or actually set this axis, and here we'd say this is the average buy price and the average sell price. Pretty straightforward. Comes down to index alignment. Of course, we've got to do this on the columns, not on the rows. And you can see in some cases we may not have an average sell price. We have nans here, so that represents we had no market information about what it would cost to buy or sell this position for that particular position. But we're able to solve this, and we can generalize this idea to any cases where I have a pandas data frame and I want to identify where did something change and group together elements that are consecutive with no change.